what you can do with it, and also some of the problems you might run into. Also talk about my experience building a serverless backend at a previous company, and the problems that we encountered and how we solved them. And then the second half will hopefully be a little more fun. We'll build our own serverless backend. So we'll build a full service that at the end will be live and we'll be able to play around with. So my hope is by the end of the talk you'll have gotten a taste for what serverless is, why you might use it, and what the pitfalls are. So the goal is to turn this, which is the live EC2 view at my current company, into this, which is what it looked like at the company where our backend was all serverless. So a little about myself. My name is Jacob Meacham. I was born and raised in Montana, in Missoula, and I just recently returned. So right now I'm the Director of Engineering at ClassPass. ClassPass is the Netflix for experiences. This is my only plug during the presentation, but we're hiring. If you're interested, come find me and let's talk. Before I was at ClassPass, I was the VP of Engineering at Doppler, which is a hardware startup in San Francisco. And at Doppler, we built a fully serverless backend. So I've had a pretty interesting journey. The company I was at before Doppler was on a monolith, so just a single server. At Doppler, we built it all in serverless, and then at ClassPass, we're on a pretty modern microservices architecture. So I've gone from servers to serverless back to servers, and so that's given me a bit of insight into serverless. So I want to start by defining serverless and sort of talking about what it is. And so the way that I define serverless is that serverless is a mindset. Probably not the slide you expected, but it's pretty new. There's not really a standard definition, and so since I'm up here, this is how I'm going to define it. So serverless sort of implies that there are no servers, but that's really a misnomer. There are servers. The interesting thing about serverless is that you don't have to think about the servers as much, which is what I mean by serverless being a mindset. The goal of serverless is to change the level at which you think. So it's an attempt to free yourself from thinking about your infrastructure, how you scale, your availability, and instead focus on writing just the software that allows you to delight your users. Another way of thinking about serverless, or another lens by which we can think about it, is that serverless is compute plus building blocks. So our goal is to glue a bunch of building blocks together with compute or functions as a service to build out a whole backend. So an example of compute is AWS Lambda. And these building blocks are generally created by others. So this is not stuff that we're building ourselves. Because our mindset is about focusing on the most important software, we're taking pieces that other people have built and gluing them together. So because we're taking these building blocks that third parties have built, it implies that we're going to be event-driven. Since we don't control the building blocks, we have to send them events and we have to receive events from them. And Lambda, or the compute, is the part that brings this all together. It runs codes on these events, so be that an HTTP event, or an insertion into a DB, or reading off of a queue. And so ultimately our goal is to offload as much as we can. There's a bunch of smart people at Amazon and Google and other places that have figured out how to correctly distribute a database and keep it up all the time. And so we want to leverage their expertise as opposed to building that ourselves. This talk is pretty specific to AWS. That's what I have experience building serverless with, but they're definitely not the only players in the serverless space. So OpenWhisk, Google Cloud, Microsoft Azure all have not only functions as a service, but they also have the building blocks that you can glue together. Cool, so you might ask, why did we decide to go serverless at Doppler? I've put a quote up here from Orson Welles that I rather like, which is, "The enemy of art is the absence of limitations." And that's really why we chose to go serverless. So when I joined Doppler, it was a very small company, about 20 people, and we had a ton of constraints. We had monetary constraints. We couldn't afford to spend a bunch on our back end. We had people constraints. The team was small, so we couldn't build up a large back end that we had to keep running. There were other hard problems that the team wanted to focus on. Scaling infrastructure was not one of those. And lastly, we didn't actually really even have the expertise on the DevOps side to think about scaling or uptime or infrastructure. And so instead of learning that, we chose to go a different route. This actually ended up being really successful for us in a lot of ways. There was a bit of skepticism when I pitched this, but I was able to push it through.
And over the year and a half that we had a serverless backend, it actually never went down. We had 100% uptime. We added features basically weekly. We were able to iterate really quickly. And our cost was around 100th of what it would have been had we gone with a standard microservices architecture. So this is what our infrastructure ended up looking like. I'm not actually going to go through this in super detail. The reason that I throw this up here is because just because you don't have as many services that you're owning doesn't mean that your backend is less complex. In fact, it's probably more complex because there's lots of moving parts. Just to point out though, there's this centralized messaging queue, and then you see in these spokes around it the lambdas, which are gluing everything together. So we didn't build a lot of stuff here. We're using Cognito for auth. We're using Elasticsearch for geotemporal search. We have Dynamo and S3 for storing lots of audio data. And instead we focused on tying this all together into something compelling for our users. This wasn't all perfect, of course. We ran into a lot of issues along the way. So Doppler joined the serverless movement really early. We started on serverless in 2015, which I don't actually think lambdas were even out of beta yet, so we were very early. And as we began building in serverless, we found limitations and things that we took for granted when using a sort of standard server design. So we had to build a lot of our own tools to make this actually feasible to do. Luckily, there was a community at the time also building up, and so we were able to sort of ride that wave, and they built a lot of tools for us as well. Some of the questions that we asked when we decided to go with this are, like, how do we deploy? So with servers, it's really obvious what deploy means, right? You take some code that's new and you put it on a server, and now you have a new version of that server. But if you have a slew of lambdas that are sort of just tying together these other building blocks, what does it even mean to version that across time? The standard DevOps rules also don't apply. We can just kind of throw that book out the window because there are no servers, and so we didn't have a lot of guideposts to tell us, like, what are the best practices here. We also asked, how do we monitor? The standard monitoring tools, like, you know, if you're used to throwing your logs into Papertrail or Loggly or Sumo Logic, that doesn't work out of the box. APMs like New Relic or Datadog are built fundamentally for servers, and so obviously they're not going to work in a serverless world. And your servers might not go down because you're not responsible for them, but stuff can still go wrong, and you still need to understand what's going wrong and be able to fix that. And lastly, we asked, like, how do you debug? Because we're outsourcing so much, we really have this cloud-first model. And so it's unclear what it even means to have a local dev environment. It's unclear if you can even develop offline at all. Like, is it possible to make meaningful progress on the back end when on a plane? Is it possible to set breakpoints when you're running code that's almost entirely in the cloud? Can you set a breakpoint and step through it, which is something that, you know, we sort of take for granted. So these are some of the questions we asked. They didn't have good answers when we started, and so it was something that we kind of had to dig into. Yeah, so that's sort of a whirlwind tour of kind of what serverless is. We're going to jump now into building our own serverless service using those questions that we asked at Doppler to kind of ground us. So let's make some memes. The service that we're going to build will let users text captions to our service. We're going to then generate a meme picture, and then we're going to text it back to them. So this is what our architecture is going to look like. At the bottom left there, our users are going to send text to Twilio, which is a third-party service that lets you programmatically send and receive text messages. Twilio is going to send a request to our API gateway, which is going to invoke a Lambda that puts requests on a queue and then returns to Twilio and says, yep, I handled this. We're going to have a second Lambda that reads events off of that queue, generates a meme, and then uploads that meme to S3. And then lastly, we're going to send that generated URL back to Twilio, and Twilio is going to text it back to our user. So even in this relatively simple service, we already see the change in mindset. The things we're going to be responsible for are the two lambdas here, and everything else is sort of done for us. But this also means that we're event-driven. We're getting events from Tulio, we're sending events on a queue, and that's what's actually driving our backend. Let's look at our first serverless function. So this is a 7-line serverless function. This is written in Node, relatively modern. It's on Node 8. So what this function does is it logs something out, and then it returns a status code in the body. So in this case, we're assuming that we're returning off of an API, and so we're returning 200 OK and giving it a message. So it's pretty cool that this is a full function. Just in 7 lines, we can upload this and invoke it. The question, though, is what do we do with this? So if you read Amazon's docs, what they're going to tell you is you're going to zip this up along with all its dependencies. You're going to upload it to S3. You're going to create a Lambda by hand and point that to your zip. You're going to create an API gateway by hand and point that at your Lambda. You're going to create any other resources you need and wire them all up and hope you didn't make a mistake. That's really untenable even for this really simple hello world style function. And it's totally out of the question for dozens of functions tying together dozens of other services. Luckily, there's a better way. So there's quite a few frameworks now around serverless. Today, we're going to use Serverless Framework, which we also use at Doppler. They came along really early, so they got kind of prime name real estate. Others have had to, be called less than something like Serverless Framework. And what Serverless Framework lets us do is define functions, events, and infrastructure that we can tie together all in one place atomically. It's open source, it's actively maintained, it supports a bunch of different vendors, so it's not just Amazon, it also supports Google and Azure. And it supports different languages as well. So we're going to write this in Node, but it also supports Go or Java or Python. There are also lots of community plugins. So Serverless Framework is probably the de facto framework right now for serverless. And so lots of people have built plugins. Chances are if you run into some issue, someone else has run into that issue and has at least given you a partial solution to it. So this is what the serverless framework definition looks like. This is called serverless.yaml. At the top we have our service definition. In our case it's very simple. It's just the name of our service. Second, we have the provider. This tells serverless where we're going to run this code and what it's going to run on. So in this case, it's Amazon and Node.js. And then lastly, we have the function. So this is where we define what functions we're going to run and how they're triggered. In this case, we have no triggers, so we'll have to invoke it manually. Cool, so this is our first function that we looked at before. And what we want to do is get this onto the cloud. So what we're going to do is we're going to deploy this using the Serverless Framework CLI, SLS. So we type SLS deploy. What SLS deploy is going to do is it's going to package up our code. It's going to create an AWS stack. It's going to wire everything together, and then it's going to return us some information. In this case, we see that we have a single function, hello serverless, and it's deployed to US East. So next, we're going to invoke that function. So we type SLS invoke -f, and we give it the function name, hello serverless. And we see exactly what we expect. So we see it returns status code 200 and the body that we expect. We can also look at the logs. So again, we'll use our CLI, serverless SLS logs -f hello serverless, and we'll tail them with -t. And what we see is we see the logs, again, that we expect. So we see a log line. We see that it took 30 milliseconds to run this, and it took 100 or 50 megs of memory. There's something a little fishy here, though, which is that to test this, I deployed it to the cloud. One of the questions we asked is how do we debug? And so that's the first thing that we're going to fix. We're going to allow us to run this offline and build the first portion of our service. So what we need to build is we have a Lambda function that's invocable. Now we need to be able to invoke it via HTTP, which is what Tulio is going to do eventually. So what we're going to do is we're going to add an event to our function. We're going to add an HTTP event. And then we're going to say that the path for that is just meme, so we'll hit it at /meme, and we're going to use a get method so that we can hit it in the browser. And then we're going to modify our function. So we're going to take the, what we want to do is use the event variable passed into Lambda and log out the meme name as the query param. I don't actually remember how to access query parameters, so we're just going to stub this out just as a reminder for ourselves that this is what we want to print. And instead of going to look at the docs to figure out how to access the query parameters or look at the logs, deploy it and look at the logs, we're going to run it locally. And the way that we're going to do that is by adding a plugin. So adding plugins is super easy. We just add a new section called plugins, and we are going to add the Serverless Offline plugin. And what Serverless Offline allows us to do is it spins up a local web server that we can use to invoke our local Lambdas. The cool thing here is that this is actually debuggable out of the box. So I've set up Visual Studio Code to debug using the serverless CLI. So what we're going to do is we're going to run the debugger, we're going to add a breakpoint to the top of our create meme function. And then at the bottom you see that we're listening on localhost port 3000. So we can grab that URL and drop it in the browser, and let's execute it. So when I hit enter, we see that we hit our breakpoint. We can take a look at our event, and we see something that's probably pretty promising. Event.queryString parameters is probably what's going to hold our query string parameters. So let's stop debugging and let's go fix our function now that we know what we should actually be accessing. So we'll change event.meme.name to event.queryString parameters.meme, and then we'll pass in a query string parameter named meme. So let's debug again and make sure that that works. Like I said, we're going to give it a query parameter here. We'll have meme equals, and what we see is when we invoke that, it shows up in our Lambda. And then if we let that run through to completion, we see that it logs out what we expect. And then in the browser, we see the message because we set it 200, so we see that we get the appropriate message. So we've solved one problem for the time being, which is debugging locally. And we've averted a pretty big issue, which is if you have to deploy and you can't step through your code, your test fix cycle is extremely slow, and it's not really feasible to actually develop. Cool, so let's tackle the next part of our service. So now we have a Lambda that's invocable via HTTP. What needs to happen now is that Lambda needs to put some data on a queue, and then we need another Lambda that reads messages off that queue and generates a meme. So here I've added some code already to our create meme function to send the message. We're just calling SQS send message. We're passing in our text, the phone number that it came from, and the phone number we ultimately want it to go to. So what we need to do now is define our second Lambda, which is send meme. So first we'll add it to our serverless.yaml. So we're going to define a new function, send meme, and we're going to set the handler to be handler.sendMeme. And then we're going to find a new event type, which is SNS, and we're going to paste in this, this resource definition. So for those who don't know, SNS stands for Simple Notification Service. It's a hosted service that AWS provides, and Lambdas are able to be woken up by notifications that we send via SNS. Next, we're going to add the code we need to our send meme function. So what it needs to do is it needs to read messages from the queue. So it's going to call handle messages and pull any messages off the queue that it needs to. And then for each of those messages, we actually have to go generate a meme. For now, what we're going to do is just log out that we need to generate a meme as a reminder to ourselves. So we'll add a to-do here. And to prove to ourselves that it's working, we're going to also log the text from the SQS message. Great. Cool, so let's deploy this. We'll use our friend SLS deploy. And we get something pretty similar back, except that we see we have something new there, which is an endpoint in Amazon. So this is the API gateway that was created for us. So we can post some data to that API using curl. So we'll grab the endpoint and we'll send it some data. I just made a simple data.json which has some test data. And if we run that, we ran it verbosely, so we see a lot of cruft, but we importantly see that we got a 200 back. And so that means that what should have happened is our create meme function was invoked, it added a message to the queue, and then it returned. And if we added something to the queue, that means that send meme should have been invoked. So let's make sure that that happened. So we'll check the logs. So SLS logs -f send meme, and we see exactly what we expect. So we see a log line for a to-do, create a new meme with this message. I've tried to sneak something by you. You may have noticed it's a long string that looks like this. This is a bit disturbing because it means that I had to make this ahead of time. So I made both an SQSQ and an SNS topic ahead of time. And it's also hard-coded, so we're no longer able to test locally. We're just using this one. Anytime that I have to test, I have to hit AWS to get to the topic. This problem has now been solved mostly. There's a relatively new project called LocalStack that bills itself as a fully functional local AWS cloud stack. This didn't exist when we were building our backend at Doppler. We had to cobble together a pretty poor version of this, but LocalStack actually works really well. And so we're going to use LocalStack and a couple of plugins so that we can regain the ability to debug offline, and we're also going to, at the same time, work on the next part of our service. As a reminder, we now have a Lambda that gets hit by HTTP, puts something on the queue. We have a Lambda that pulls stuff off that queue and has a to-do to generate a meme. So the next step is that we actually have to generate the meme and upload it to S3. And ideally, we do that without so much hard coding. So the first thing we're going to do is we're going to add two new plugins. The first is Serverless Plugin Deploy Environment. And the second is another offline plugin, which is SLS Offline SNS. And what the first plugin allows us to do is define environments and with variables in them, and then refer to those variables either at deploy time or at runtime. So with the aid of Serverless Framework, it also lets us spin up new resources programmatically in different environments. And then the second plugin, Serverless Offline SNS, lets a local stack topic trigger our offline lambdas. So adding the first plugin, Serverless Plugin Deploy Environment, added a couple new files that we're going to take a look at. So the first is variables.yaml. And what this has is definitions for variables that are around at deploy time. In this case, we have three different environments. So we have a local environment, we have a develop environment, and we also have a production environment. And we see a couple things. For example, bucket name is the name of our service-local and local, name of our service-develop and develop, and certain name of service-production and production. We also see that in local, we're pointing our SQSQ URL to localhost, and we have a dummy SNS topic in there. The second new file that was added is deploy.yaml. So these are passed into our Lambda at runtime. In this case, we have some defaults at the top that are used for accessing our sources. Those variables just come from that variables.yaml we just looked at. And then in our local environment, we also have some overrides for accessing just our local stack. So we're going to do a couple of things now. First, we're going to actually go generate our meme and upload it to S3. So what that's going to spit out is a media URL. We're going to call memecanvas.generate and upload. And we're going to pass it in the text that we want for the meme, as well as the S3 bucket that we want to upload it to. And then we're going to log out that media URL, just again so that we can prove that this works before we actually send it via text message. Cool. The next thing we're going to do is now replace our hard-coded strings. So we're going to remove that SQSQ URL and replace it with process.env.sqsq URL. This is passed in from our variables.yaml. We're going to do the same thing up above with our Q URL and our SNS topic. And then we're also going to change the hard-coded topic in our serverless.yaml. And this will use the deploy variables because this happens at deploy time. Cool, so nothing is hard-coded now. We've removed all of the resource definitions, which means that theoretically we should be able to run this locally or run this in the cloud. And so we're going to try debugging again to prove that that works. So we're going to run the debugger. We're going to put a breakpoint in send meme, which is the second lambda in our chain here. And we're going to then post some data to our local listener. And what we see is that we hit a breakpoint, which is cool. And we also see that what we expect happens. We output a meme URL. Notice that that URL is local, so we actually never went to the cloud. This could have happened completely offline. Let's grab that URL and paste it into Chrome and see what happens. Awesome, so we generated our first actual meme. This happened all locally, so we have a local SQSQ, we have a local S3, and we're invoking our lambdas locally. That's pretty cool, and even more cool, I think, is that we're going to now deploy this and see the same thing running in our develop environment. So we're going to deploy as usual, SLS deploy, but we're going to add a new key here, which is --stage develop, which tells us to deploy to the develop environment. It looks pretty similar to what we saw last time, except at the end of our URL there, which is a cloud URL, we have /develop, so our environment is baked directly into our API gateway. All right, so we're going to grab that and we're going to post some data to it. And it succeeded. So that means that create meme was invoked. Let's look at the logs for send meme and see if those were invoked. Again, we'll pass in stage develop so that it knows that we're talking about the developed version of the send meme function. And this is exactly what we expect to see again. We see that we generated a meme from some message and we have the URL for it. And notice this time the URL is an S3 URL. So this happened all completely in the cloud. So let's grab that URL and download that again. And what we see is a second meme. So we used the same code. We made absolutely no changes. All we did is add a different switch to our CLI, and we deployed both locally and then in the cloud. So this makes it really clear what our continuous deployment pipeline should look like. Again, we didn't have local stack at Doppler, but we had something similar. And so locally, you can use local stack to develop and debug, and then you can run the unit tests against your functions. On your continuous integration server, you can run your unit tests again, but then you can also run integration tests against local stack, so all running just in that CI server. And then you can push to staging or a develop environment and run those same integration tests again, but running against the actual AWS services. Only if all of that passes, then do you push to prod. All right, cool. So our meme has now been generated. We have an HTTP function that invokes a lambda. That lambda puts data onto the queue. We have another lambda that generates and uploads a meme. So the last step is we need to tell Tulio where that URL is, and then Tulio will text it back to our user. And then we also need to have Tulio call our API on the front end. The code for this is actually very small. There's not much necessary to make it happen. So we just have to call Tulio client.messages.create, and we pass it in the phone number that we want to text to, and as well as the URL of that media. I also added a Tulio webhook. They just have a UI for this, but I took that exact same URL that Serverless spits out and put that into Tulio. So that means that our service is complete. Before this talk, I deployed to the production environment. So this is live. You can text this number, and I encourage you to do so. how it works is it splits on periods. So if you have 2 sentences in a single text, you'll have top and bottom. If you just have 1 sentence, it'll just show on the top. I'll leave the number on for the rest of the slide, so don't worry, you don't have to do it really quick. But since we built this, we should try it out. So while everyone is getting memes texted to them, let's talk a little bit about the cost. So this is the cost formula for Lambdas. It's the execution time times a dollar amount per megabyte used times the number of invocations. So for us, we have 2 Lambdas. Each of them take around 1,000 milliseconds to run. Let's say we have 20 million requests. So we have 2 Lambdas, which means we can generate 10 million memes. And this is the current very small number of dollars that AWS currently charges per 1,000 milliseconds for 128 megabytes. So that comes out to less than $40 a month. This isn't all in. We also have a bit of cost on SQS and S3, but my expectation is that we would be less than $60 a month to generate 10 million memes a month. Tulio is actually really where we get bitten. It turns out that it's relatively expensive to send texts. But what's even cooler about this formula is that it's really fungible. So if each of you tell your million friends about this, and we actually have to generate 100 million memes, we essentially just multiply our cost by 10, and it costs me $400 a month. If instead we only generate 1 million memes, then it's just going to cost me $4 a month. And I didn't have to do anything to make that cost structure happen. It just sort of scales automatically for me. This service is also less than 150 lines of code that we had to write. So I hid a little bit of library code away just to keep it a little simpler as we were writing it. But even with the library code added in, the entire service is less than 150 lines of code. I think that includes white space as well. I don't think I pulled white space out of that. You might ask, is our service ready? And I think the answer is a resounding kind of. We have a lot of stuff, but we didn't talk about a lot of things as well. So we didn't talk about security or authorization. Right now, anyone who has that URL can hit it, not just Twilio. Those Lambdas have quite a bit of access to AWS, so if someone was able to get into them, they'd be able to do some damage. We didn't talk about alerting or integration with something like PagerDuty. So if all of you are texting and getting nothing back, I will not be told about that because there's no alerting. And we didn't talk about secrets. So right now, if you need secrets, they would just be splatted into your Git repo or whatever, which is obviously not ideal. But we do have some stuff that you wouldn't usually expect to see out of a 45-minute presentation on stage. We have a full local dev experience. We have full production and develop environments. And we have a really clear path to running continuous integration and actually continuously deploying to our server. We also sort of get for free that effortless scaling. So we didn't even have to do anything, and it can go from, this will cost me a few cents probably over the lifetime of this service, but if it suddenly became very popular for some reason, I don't have to do anything to make sure that happens. So I would say that our service gets like a B- right now, but I don't think it would take that much to get it to an A. Like any good salesman, I haven't really mentioned the downsides yet, but let me take off my salesman hat and put on my engineering cap and talk a little bit about downsides intrinsic to serverless. So right now, serverless is still really new, which means, like we talked about, a lot of tools don't exist yet or aren't quite as good yet. But it also means that if you have a serverless backend, candidates aren't going to be familiar with it, so there's going to be a spin-up time as new people join your company. Vendors aren't going to support it or know what it is, and so you really do run into a bit of friction there. You also can become pretty locked in because we have this new mindset where we're only focusing on writing the code that's most important for our users. We're using a bunch of building blocks that someone else owns, and so you're relying on someone else to make sure that your service is successful, which means you're probably locked into a vendor. Similarly, we're trying to hit a moving target, and because you control less of the overall stack, you have less a say in how that changes. An example here is that AWS just recently deprecated and removed an old version of Node, and so a bunch of Lambdas that were running totally fine, doing great, had to get redeployed onto some new version of Node. And lastly, serverless isn't suited for all applications. So Lambdas have a couple of interesting constraints. They can only run for 5 minutes. They can only use up to 2 gigs of memory. They have cold starts, so the first time that one's invoked, it might take a couple seconds longer than in the steady state. And so if you have services that are long running or need to listen, a WebSocket say, or servers with a lot of state, or something that requires specific memory or execution constraints, like it always has to respond within 100 milliseconds, then serverless is probably not necessarily for you. Awesome. So we put together a pretty compelling service in around 40 minutes, which is pretty cool. And I would say my 3 key takeaways are, first, serverless is a mindset. It's changing where you think about your stack and where you spend your calories. The second is that it's possible to build a serverless service today. There are lots of companies whose backends are wholly or almost wholly serverless, and there are lots of benefits to doing so. And then the third is that there are definitely pitfalls as well. We've walked through a couple of them, and so if you end up trying serverless out, hopefully you'll be able to avoid them somewhat. All the code for this is up on GitHub. It's structured in the same way that we walked through it here, so you can sort of follow along again at home. If you scan this QR code, it'll send you right to the code repo. Otherwise, it'll be up in the video when that goes up. Cool. Thanks a lot, everyone. Does anyone have any questions?